Logarithms. Even though math uses it to simplify stuff, we find it a bit tricky to understand. So let's learn the basics properly. The way we write a logarithm, or a log for short, is with log, any number, and our base. So a is our base and m is any number you want. Now there are some rules for the base that we use, or the base that we get. So for a logarithm to be proper, a, or our base, cannot be equal to 1. It should also be greater than 0, and most importantly, a has to belong to the real numbers. So that means a can be a fraction, it can be a decimal, it can be anything you imagine, as long as it fits into these conditions. That's the condition for any logarithm. Now, keeping this kind of logarithm aside, we're going to move into our second type of logarithm. Now, you're going to see that as ln standing for natural logarithm. And the only difference between natural logs and our normal logarithms is that it has a base e. Now, e is a number between 3 and 2, and it's called the Euler's constant. The Euler's constant. Now, natural logs are read the same way, they're written the same way, they have a few extra rules, but the only difference is the base. Now, the second important thing you have to know when you're dealing with logs is how to convert something in logarithm form to something in exponential form. So, for example, say you have log 100 to the base 10. The first step into converting a logarithm into something exponential is equating it to something, a variable. So for that, I'm going to say log 100 to the base 10 equals x. Secondly, the base in our logarithm remains the base in our exponent. Then the variable that we equated it to turns into our power. And lastly, the number that we used in the log gets equated to. So since we do AA math, we know that 10 to the power 2 equals 100, therefore x equals 2. Simple, right? Okay, so for the sake of practice, let's do another one. Say we have log 300 to the base 5. Now remember, the first step is equating it into a variable. I'm going to say the variable is y. Next, we know that the base we have in the logarithm is the base in the exponent, and the variable turns into the power. Next, we know that the number we used in the logarithm turns into what we equated to in the exponent. So we can't simplify further without using a calculator, so we're just going to leave it like this. So using this and getting thorough with the exponent laws, you can solve any log by converting it into an exponent. Okay, so let's move on and learn about the logarithmic properties using a function. So a logarithmic function is going to look something like this. Let me start a bit better. We're going to move up like this, and it's going to curve out here. It's going to look much more smoother, I promise. And we're going to name our axes y and x. The equation for this logarithmic function is y equals log x. I'm not stating a base, therefore the base is automatically 10. And notice two things in this diagram. First, there's an intersection point. Secondly, the y-axis is an asymptote. Notice how my function never touches the y-axis. That's called asymptotic behavior. Okay, so let's try to find out what our intersection points are. So to do that, we know that our y should be equal to 0, and that's going to give us 0 equals log 10 to the base x. I'm going to convert these quickly using what we learned before. Therefore, 10 to the power 0 is equal to x, and x is equal to 1. So when y equals 0, x equals 1. Therefore, the coordinates of our intersection point right here is 1, 0. Done. Now the second point that we notice, or the second factor that we notice, is the asymptotic behavior of the function. So let's find out why that is. First of all, the equation of the y-axis is x equals 0. This is important to know. Now, using our function equation, or the function y equals log x, let's plug in 0 into x and find out what we get. So y equals log 0 to the base 10. Let's convert it using the conversions that we learned. So the base stays the base, the variable goes on top, and finally we have our number. Now when y belongs to real numbers, this is impossible, meaning that a solution does not exist. That's the reason why x cannot equal 0. That's how a logarithmic function is formed. Okay, so since we know the properties of logarithms, let's move on to the log rules. The first rule of logarithms is the addition rule. So addition rule. Now, to summarize the whole addition rule, it just states that when you're adding two logarithms, the numbers get multiplied. So that's going to look something like this. Log a to the base m plus, log m to the base a plus log b to the base a equals log mb to the base a. This rule is only valid, this or all the other rules are only valid when the bases are the same. See, you got a and a. So to practice what we just learned, let's do a quick example. Say you have log 10 to the base 2 plus log 20 to the base 2. So using our rule, that should be equal to log 10 times 20 to the base 2, which is just log 200 to the base 2. That's how the addition rule works. Secondly, similarly, we have the division rule. So this is the division rule. Now, to summarize the whole division rule, the division rule is when you subtract logarithms, the numbers get divided. That's it. So that's going to look something like this. Log m to the base a minus log c to the base a equals log m divided by c to the base a. Notice how it's still the same bases. That's the important part. So to practice, let's do a quick example. Say you have a question that says log 100 to the base 10 minus log 50 to the base 10. Now, what's that equal to? Well, we know about the division rule, and this is a subtraction, so that's going to give us log, same base, 100 divided by 50, which is just log 10 log 2 to the base 10. That's it for the division rule. Now our third rule is called the reciprocal rule. Now that's going to look like this. Log m to the base a equals 1 over log a to the base m. So if you notice, this rule is just to switch the number and the base. So for example, say you have log 10 to the base 2. And imagine for a question you have to use this reciprocal rule. So what are you going to do? Well, you'll have to make it a fraction, so 1 over log 2 to the base 10. You swap the base and the number and put it as a reciprocal. That's it. Simple enough. Okay. Moving on to our fourth rule. Now the fourth rule is called the base change rule. So number 4, base change. So it speaks for itself when it says base change, because it's all about changing the base of a logarithm. And that rule looks like this. You're going to have log m to the base a, and that's going to be equal to log m to the base b over log a to the base b. So to explain the equation, a is our first base and b is the second base that we change a into. So to do that change, we're going to have to put the number in the numerator with the new base, and we're going to have to put the old base with the new base in the denominator. I know it's confusing, so let's do an example to understand it. So we're going to have something like this. Say you have log 10 to the base 2, and you want to change the base 2 into base 3. So we're going to have log 10 new base 3 in the numerator, and for the denominator it's going to be log 2 to the base 3. 2 is the old base, and 10 is the number, and 3 is the new base. That's how you do it. Since it's confusing, we're going to do one more example. So for this example, we have log 3 to the base 15. And we're going to turn this into a logarithm with a base 5. So like the rule states, in the numerator it's going to be log with the new base 5 and the number, which is 15, over the denominator, which is log with the new base 5 and the old base. That's it. That's the base change rule. And lastly, the last rule you have is a simple one, and it's called the power rule. So imagine you find a logarithm that is going to look like this. Log m to the base a with m to the power b. Now you can take that exponent and write this logarithm as b log a b log m to the base a. Now b is just multiplying this whole log, and that's just the power rule. So for example, say you have log m to the base a with m to the power, let's use numbers, log base 3, log 5 to the base 3 with 5 to the power 6. Now you can write this as 6 into log 5 to the base 3. That's it. That's the power rule. Now that sums it up for the whole logarithm section, but with ln or with log and ln, there are a few tips and tricks that will make your life easier solving these logarithm problems. And there's plenty in those questions that you receive. So first, log a to the base a is always going to be equal to 1. That's because this logarithm has the same base and the same number. Okay? That's one. Secondly, log any base, log 1 to the base a, where a can be anything like we stated, is always equal to 0. And these are the laws for logarithms, or the tips for logarithms. Now let's move on to some ln versions of these tricks. So ln e to the base e is equal to 1 because it's the same base and the same number, and ln1 is also equal to 0. Additionally, ln e to the power x is x. Why? Well, this is a combination of this right here and the power rule. Firstly, let's break it down. We have e to the power x. Firstly, we're going to use the power rule and bring x times ln e, because we're going to bring x from here to over here. Now, using this law, where the same base and the same number is equal to 1, we know that ln e to the base e is equal to 1, therefore x into 1. That's just equal to x, and that's the law. Now, one more special or tricky one that you use a lot when you're using logarithms to solve exam-style questions is this. X equals e to the power ln x. Now this is important, or x is equal to this, because since there's a base e here, this gets cancelled out. Therefore, x is equal to x. That's it. Those are the basics for logs, and before we get into solving logarithms and solving questions, you need to be thorough with all of these properties and all of these rules. So practice these questions. You have it in your textbook and resources all over the internet. Get used to them and have them in your mind. Okay? See you in the next one.